morning, ladies and gentlemen. I hope your day has started out well. You guys did a good job starting out class, but let's see what kind of rate of success we had with this. So, tell me, what is the difference between the measures of AB, arc AB in the large circle, and the AB, arc AB in the small circle? Or actually, bigger arc minus the smaller arc. So let's see how we did. I got student 6, 16, 13, 18, and 3. Student number 6, what'd you get? Student number 16. Not here. Student number 13. Student number 18. Student number 3. So I got 4 students who agree that it is 100, or 3 students who agree that it is 100, and the correct answer is 100. So, let's start simply, and then for the students who are having trouble seeing what they need to see, I'll modify the diagram. So, could someone give me what you did for the small circle? What did you do for the small circle? I don't want crickets, I want lions. What did you do for the small circle, Davis?
The angle is 70.
Correct.
And we did 70 equals 1/2 of AB plus CD, and since CD is 20, we would write it as 70 equals 1/2 AB plus 20.
Very good. So you could write measure of arc AB instead of an X. Just for simplicity, I put it in X, although I should be careful because X was used in the diagram, but I'm using my own X separately. So solve that equation, and you get the measure of this arc. What was the measure of this arc? Tristan? Was it 140? Okay. You solve this equation and it comes out to 140? Oh, so you did something else and you got 140? Okay, what did you do to get your answer for the small circle? Because this arc right here will be... Good. Could someone tell him the flaw in his thinking? Why is that incorrect? I only have 3 people who know. That bothers me. Why is he incorrect? You see this in your homework all the time. Correct the mistake that this student made. Anne. Okay. That's right. No, well, no, that's... He said that this will be twice this. Right. So I'm sorry. Yes, the vertex has to be a point on the circle. That's right. You're talking about a different idea. So we talked about angles, arcs, and their measures when there's a central angle, arcs when there's measures when the vertex is on the circle, but this is different because this vertex is not on the circle, and it is also not a central angle. That was the whole point of the lesson. That angle can't be found by either of those 2 methods. You have to do this. So could someone tell me the correct measure of arc AB? Catalina? So this comes out to 120 degrees. Could someone or several other people help us? What did you do for the large circle? What did you set up for the large circle? I'm sorry, I'm asking the wrong question. Give me a thumbs up if you got the right answer. Thumbs up if you got the right answer. Good. Give me a thumbs up if you used magic. Okay. Zabari, what did you do for the large circle?
I set up 70 equals 160.
Okay. Or That expression divided by 2 is the same thing. And Zabari, when you solve that, what did you get for the measure of this arc right here?
20 degrees.
That's 20 degrees. And I asked for the difference between the two. 120 minus 20 is 100. So this is all based on the previous lesson about the relationships between the angles formed by intersecting lines and the arcs that they intersect. For those of you who had trouble seeing it, what you needed to be able to do was focus on the information that was needed. And so it might have behooved you to draw 2 separate pictures. Because if we get rid of all of this, it actually becomes a very simple idea. You're told that this arc is 20. It's a straight theorem. There's no thought really involved. You just have to be able to recognize it. Does anyone have any questions or issues with that? Any concerns? Okay. So, 10.6, segment relationships in circles. Our goals for today, our objectives are to be able to find lengths of segments when you have intersecting lines intersecting circles, and use those ideas to solve problems. You're going to hear some new terminology today. You've heard secant, external secant segment and tangent segment. You've heard that as well. Never quite said the part of segment on the end of it. And you should have your cheat sheet out. If you would take the cheat sheet out and find the theorems, ideas, and concepts that are going to be explored during this lesson, and if you would read those to yourself for a moment. Take a moment to do that. Okay, so you've had a chance to look through what you're going to be exploring. Some pretty wordy theorems. It's a little bit hard to tell from reading them what is going on, but if you look at the diagrams, things become much more clear. So let's quickly review these ideas and then put them into practice as quickly as we can. So, the first theorem we're going to explore is called the segments of chords theorem. Let me back up for a second. Last time we were together, we explored the idea that there is a relationship between the measure of this angle and this arc and this arc. The measure of that angle will be half the sum of these two arcs. So there's a relationship between the angles formed by intersecting lines and the arcs that they intercept. But Davis, there is also a relationship between the segments that are formed when you have lines intersecting in a circle. In other words, there is a relationship between this segment length, that segment length, that segment, and that segment. And the relationship is the product of the two segments is going to be equal to the product of those two segments. And that's what you see illustrated right here. The segments, so this point is cutting the chord into two segments. Those two segments multiplied together will equal those two segments multiplied together. Any questions about just the basics? All right. Then we have the segments of secant theorem. You know that a secant is a line that passes through the circle but continues outside the circle, versus a chord whose two endpoints are points on the circle. The segments of secant's theorem says a similar relationship, but not quite. This part of the secant is called the external secant segment, or we'll just call it the external segment. The product of the external segment and the whole secant will equal the product of this external segment and the whole secant. And that's what's illustrated here. This is the external segment times the whole secant, external segment times the whole secant. Any questions about that? And then finally, if one of the secants was changed to a tangent, how would that affect the relationship? Well, this tangent is not being broken into two segments, whereas all the other ones were broken into two segments. So what do we do with that? Well, now we square the tangent, the length of the tangent, and then the other side of the relationship stays the same. External segment times the whole secant. And that's called the segments of secants and tangents theorem. As always, the idea is the most important, not the name of the theorem. Any questions before we jump in? All right. Last lesson, I gave you a whole sheet of of all the diagrams that were used within the lesson. Today's quite the opposite. A sketch of the diagram will be sufficient for these. So we have this diagram, and we're asked to find the lengths of each chord. We have chord AB, and we have chord DE. The x's that are being used as variables to represent lengths. So this length from here to here, and there's no label for the center, which is my mistake. From here to here is x plus 5, and from here to here is a measure of 6. From here to here is a measure of x, and then from here to E is a measure of 12. Find the length of each chord. Because we have intersecting lines inside the circle and both chords, they're both chords, so the endpoints are on the circle, we can use the first theorem that was outlined today, the segments of chords theorem. The product of the segments of one chord is going to equal the product of the segments of the other. So if we take AB, we've got 6 times x plus 5. That's the product of the two segments. Will equal the product of the two segments in the other chord. 12 times x. Solve the equation. You guys don't need guidance on that. Go ahead, solve the equation, give me a thumbs up when you've got it. I don't need to put up a clock. I've already got a few people who did it. Some people can do it mentally. That's good. 1, 2, 3. Put your thumbs down. All right, Jada, what do you get for x?
5.
X equals 5. But that's not what we were asked for. We were asked for the measurements, the lengths of each chord. So we need AB and we need DE. What is the length AB? Joe? Is 16, very good. And what is the length DE? Brian? 17. Very good. Any questions on how we use the segments of chords theorem to set up this relationship that we then solved to find what we were looking for? Any questions about that? Any questions? Okay, so that's when both lines are chords. They're both inside the circle. When one or both of the lines extends outside the circle, the relationship changes a little bit. So you have to pay attention to what you're doing. Again, a sketch of the diagram will be sufficient. So go ahead and take a moment to just set up a sketch. So, when we have two secant lines, the relationship becomes the measure of the external segment, this measure here, times the measure of the whole secant will equal the measure of this external segment times the measure of the whole secant. So, the external segment for this first secant line is 6. But what is the measure of the whole secant? Sebastian? Yeah, you have to add them together. So you've got 3 plus 6 is 9, so you get x plus 9. That product will equal the external segment, x, times the entire secant. So you have to add them together. What do you get when you add those together? 5x. Very good. So we use the relationship to set up an equation that we can then solve for the value or values of x. So go ahead and solve the equation. You don't need my guidance for that. Give me a thumbs up when you've got it.
What?
What is it, proving harder than we thought?
Yes. I don't remember how to do that.
Oh, what happened? What did it come out?
Are we?
So let's see. So we ended up with 6x plus 54 equals 5x squared. Oh, it's quadratic, huh? So if we move everything over to the right, so this stays positive, we end up with 0 equals 5x squared minus 6x minus 54. And so now we need to run through all the different ways of solving that. Yeah, that's unfortunate. So what are you trying to do? Someone help me out. What are you trying to do, Alicia?
Oh. Kind of like a reverse factory. Like instead of trying to get that equation, you're trying to put 2 into.
Right, that's not reverse factoring, that's called factoring. So yeah, it would be awesome if we could just do this, equals, and try to find 2 linear factors for 5x squared minus 6x minus 54. Remember how we did that last year?
No.
That's unfortunate.
I tried to see how, and I got 3, but I pumped it back in and it didn't work.
Yeah.
Oh, there.
What else could we do? Factoring's proving difficult. What else could we do?
Sorry.
I heard it hollered out. So do that. Quadratic formula. That's what it's there for. Okay, go.
I'm so confused.
What's the problem?
This is last year, Mr. Galli. I'm expecting too much from it.
No way, remembering something we
This is-
memorized.
This is no big deal. You guys are making it more than it is.
No, wait, just give us a second. Give me an hour.
What's that?
Is it? I don't like it. The Y.
Ladies and gentlemen, okay, I understand that it's difficult to remember some things, but you should remember that this is A, that's B, and that's C.
That's what I was doing.
So,
Look, I was doing it. I was guessing, but I didn't.
come on, let's go.
Yes. Oh, so
Yeah.
wait, you explain the next one.
I hated that.
Yes. I wish it was old people, man. They just do
Square. I mean 36. So would it be x squared?
Sebastian's great.
I don't know. Mr. So, okay, then we do squared. Did you get the x part? Mr. Gallet, when you squared b, right? And it's already negative 6x squared, would it become 36x squared or 36x?
Wow, you guys are just butchering this.
I don't remember. I already had a problem with x. Okay, what about
That's not what you're butchering. A is the number, not the variable.
someone have a
Man, I clearly am the worst algebra teacher on the planet.
It's not bad.
Because you guys retained nothing.
So
Yes.
No, I got 6 plus or minus the square root of 36 minus 1,080. 1,080.
Ladies, gentlemen, my little prodigies.
Wait,
A,
take some
B, and
time. We're
C.
getting it. We're getting it.
A is a number, B is a number, C is a number.
You don't divide by 2 that's so hard. You square that.
It's negative 24.
And then you divide by 2.
Negative 4 times 5.
Guys with the same. Yeah, that's what I got.
Why would it be negative? Wait, did you know I heard you?
Did you get?
Isn't it positive? And then positive 1,000. I don't even know what I'm doing right now. I'm not following you. What's the square root of that?
Wow. I've never heard
Makes sense.
rudeness in my life.
Look at that value up there, that's 6.
Times 5.
Makes sense that 39.4
Wait, what did you do?
makes sense for the other one. I know the
How did
pictures.
you get that?
What?
Yeah.
Can it be negative?
No.
Yeah.
Did you do this?
Oh, that's right. No, I don't.
Oh my goodness!
What's up?
I just deleted all of my work on the podcast.
Okay, so
Wait, more time.
it's important to be able to pull things back from the past, and I do value giving you time to wrestle with things, but we're wrestling at this point with little minute details like a couple of negative numbers and maybe forgetting to divide by 2a and stuff like that. So was anyone able to arrive at an answer? We got a couple of people, so we'll start. Oh, we got quite a few people. We got Zabari, Sebastian, Alicia, Brian, Davis. What'd you get? Okay. 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 Yeah, x is going to equal 3.94. You do get another value. You get another value of negative 2.74, but unfortunately that can't work because this distance cannot be negative, so a negative number will not work. And so the only answer is, and I should have used the approximately equal to, this is approximately equal to 3.94. It's not exact. So if we did plug it in to check it, if we plugged it in here and here and here and checked to see if it worked, it wouldn't work exactly, but it would work. It would be very, very close. So if I have time at the end, we'll go through the quadratic formula again, but I want to make sure that we get through all the geometry work before we spend any more time on algebra. So I apologize for tripping you up a little bit, but that was not my intent. Let's go back to the geometry. Does anyone have any questions about these relationships that we were able to set up using the theorems, the segment theorems? Any questions about these relationships that we were able to set up? Any concerns with that? I know there's concerns with quadratic, but is there any concerns with setting up the relationships? Okay, checkpoint number 1. You do not have to draw the diagram, you don't have to write the question, just write CP1 and find me the value of x, round your answer, round any decimal answers to the nearest tenth. Got 3 minutes on the clock. If you finish before time is up, check your answer with your team. We're starting out independently, and then you can work with your team after you have an opportunity to work independently. If you want to.
I did.
Outer inner
Oh, that was actually.
That's wrong anyway. That's supposed to be that's you screwed up at the very beginning.
Got it?
Can't speak at the beginning.
What is it called? When you multiply two binomials together? Technically.
What? Wait, what? No. How do you guys talk math stuff? How do you say 10 minus 2? Yes.
Now you're making your life miserable. 'Cause
Why?
I'll put a couple more minutes on the clock so that you can deal with the algebra, but now some of you are making your lives incredibly difficult for no reason. You think you got the answer already and you don't want to wait, you know? That's well,
Did you?
you guys are done? I have no idea what that is. Very good. You did awesome. You did all the hard work. Yep. So, okay, so we had some success, and some people unfortunately couldn't even remember how to do just the basics from multiplying polynomials from last year. That's okay, that's understandable to some degree, but you have teammates surrounding you, you should have been able to ask a quick question. Things should have started coming back. It's the old adage of how long would it take you to get back on a bicycle and ride it, having not ridden it for a year. You might be a little bit wobbly the first time you get back on the bike, but it should come back to you pretty quickly. So if it didn't, it doesn't make you a bad person, but it's something you're going to have to work on. So let's get answers first. I won't torture you guys. I'll just take volunteers so that I'm not putting people totally on the spot. We'll start with Kayla, Catalina, Maria, and then Brandon. What'd you get, Kayla? So, I'm going to jump to the point where some of you got messed up. You end up with 8x minus 4 equals x minus 2 times x plus 7. This was the first hiccup for some of you. How do you deal with this product? How do you deal with that? And FOIL it. First, outer, inner, last. You FOIL it. You get 8x minus 4 equals x squared plus 5x minus 14. Now everything needs to come to one side, so all of this needs to come over to the right, and you end up with 0 equals x squared minus 3x minus 10. You are more than welcome to use the quadratic formula, but if you are making your life much harder than it needs to be. If there is a 1 right here, you should easily be able to factor this like Alicia had indicated earlier. Unfortunately, the example we did earlier wasn't factorable, but this one is. And it's super easy to factor because you already know it's going to be x and x. So Brandon, what are the two numbers that, or tell me the whole binomial. What's this going to be and what's that going to be?
The first parentheses is x minus 2, and the other parentheses is x plus 1.
X minus 2 times
Wait,
x
switch
plus
those
5.
around. Switch those around. Positive 2 and negative 1.
Sorry. X plus 2 times x minus 5. Right, so because we need the negative 3 right there. Solve both of those. It's a zero product property. X plus 2 equals 0, x minus 5 equals 0. You get two solutions. You get x equals negative 2 and x equals 5. Cannot have a distance that's negative, so you end up with just 5. So again, I am sorry that if you were not able to remember from last year how to deal with this and how to deal with this here coming from that there. Any questions at this point? Please don't lose sight of what's most important. The most important part is learning the geometric ideas that are involved. Any comments or questions? Okay, so let's continue building our toolbox of tools. We now have two tools that we can use to find lengths when you have intersecting lines intersecting a circle. The last tool is called the segments of secants and tangents theorem. So we have a tangent, and we have a secant, and they're intersecting at a point outside the circle. What are the lengths of those two segments? So take a moment to sketch the picture, and then we will begin working. So, the segment of secants and tangents theorem is similar to the segments of secants theorem, except because this is a tangent and not a secant, it's not being divided into two segments. So we can't multiply anything, but we sort of can. Instead, we square this value. So from the theorem, we can set up an equation. X squared, so the tangent's length squared, will equal the product of the external segment, x minus 2, times the entire secant. So now we have to add these two together to get the distance from here to here. So what do we get when we add those two together? Davis?
2x minus 3.
Very good. 2x minus 3. Now, solve. This time I will work with you, so clearly over the course of today we've discovered we have lost a little bit from last year, so let's recover all of that. X squared is going to stay, but we need to FOIL this. So FOIL, the f's are the first terms. X times x squared, you get 2x squared. The outer terms is going to be x and then negative 3. The inner terms is going to be negative 2 times 2, so that's a negative 4. The whole point of FOIL is because if you do it right, the outer and the inner terms should add together. They should be like terms. So we end up with a negative 3x and a negative 4x. Add them together, we get negative 7x. And then the L in FOIL is the last terms. -2 times -3 is a positive 6. But we have this x squared sitting over here as well. To solve a quadratic, we need everything on one side. So we subtract x squared from the left and from the right, and we get our 0 equals x squared minus 7x plus 6. You are more than welcome to do the quadratic formula at this point. If you can remember, x equals -b plus or minus the square root of b squared minus 4ac over 2a. Wonderful, you should. You guys worked hard on memorizing it last year. Hopefully it will come back to you. But at this point, when you see a 1 right here and you see small numbers here and here, you should be thinking to yourself what Alicia said, which is, I should be able to factor this. Not all quadratics like this can be factored, but you should definitely give it a shot. Because you already know that the first terms must both be x's. So now we just need two numbers that multiply to this and add to this. What are the two numbers? Alicia, you started all this. Go ahead. X minus 6 times x minus 1. Because that will FOIL back to x squared minus 7x plus 6. And then to get the values, you set each factor, that's a factor, set that equal to 0. And that's a factor, set that equal to 0. And solve. And we get x equals 1 and 6. Now plug them back in to see if they work. Right? 1 doesn't work. Okay, let's see. 1 minus 1 is 0. That clearly will not work. So we will disregard this answer because it doesn't work. The only valid answer is 6. Let's see if the 6 works. 6 squared would be 36, and that would be 4 times 9, which is 36.
I do the quadratic formula, and for when it's plus or minus, and like you're like on the last step and you're doing divided by 2, does it usually only work for like in these cases? Would you only do the plus because all the minuses come out like 9? They don't work.
I don't think that will be every time. I think that's sometimes. Because it is possible that you're doing the expression after the plus minus symbol could be smaller than what comes before it, and you'd end up with positive numbers. So it is possible that it would work. Okay, but that's a good question. And we'll have to pay attention moving forward. Okay? So, again, a lot of our work revolved around algebra, not really the geometry. Does anyone have any questions about the geometry involved? Okay. Checkpoint number 2. You do not have to copy anything, but I want to make sure that you guys can see the measurements that are involved. So you're going to have to read this, but before you read, I want to point this out. This says 83,000 kilometers from C to D, and from A to D is 203,000 kilometers. You should try to pronounce these names to yourself, but don't worry if you can't pronounce it properly. They're unusual names. And so I am looking for the distance dB. All right? So it's going to take a little time and a little effort. Good luck. Got 5 minutes on the clock. If I need to extend the time, I will. I have no problem with that. If you need some guidance, you let me know. You might come across a calculator issue. If you do, you're going to have to try and figure out how to deal with it. There is a way to do this. Yes. That's scientific notation. That means that times 10 to the 10th power.
No, Brandon, that just makes it deeply wonky. Probably even know that.
That's scientific notation. That's not to the 10th power. That's times 10 to the 10th power. Scientific notation. Maybe.
See, look at that, you're telling me conference starter. Do you want to go? Do you? Beautiful.
83,000 times.
Make sure you're not getting caught up in the largeness of the numbers. Focus on the geometry. What is it that you're supposed to be doing? Set things up first before you dive in with the large numbers. Also, maybe there's a simpler way to do it without large numbers. Think about what you're doing. I'm going to extend the time a couple of minutes.
I know we have D, but like before we go.
1 second.
The radius.
Take away the zero.
Yeah, you can grab that. You're messing up my brain.
Stop.
For the pivot. For the.
Oh.
Yeah, for the.
I love it.
Isn't that just stupid as a point I remember doing this.
That's where you guys do
Never mind.
What do you mean 6 zeros? But since you wait, so add 200 squared.
I thought you meant you were subtracting like that.
Get out of here.
With 83
Can't we get these? Minus.
Close. Close. You can round it a little bit. Why do you do it? Relationship is square times I'm sorry, the segment outside the external segment times the whole.
Goodbye, Brandon.
I'm almost
Wait, so that's
You can't, you gotta erase all of it.
Oh, right. Thank you.
Did you guys get this?
It's a lot of squares.
Sir, did you get this? Did you get this? I got that too. You got your by the way. So that's off like 193. And that gives you BC. Now add BC to CE. That's
Yes, but
Oh, you divide it by that? That would have been a great approach. Good, but now you didn't answer the question.
Oh, I don't know, I didn't do that,
I know I can
the
do
step
that.
before that.
Oh, so you said three.
Okay, so again, because of the complexity, I don't want people to feel badly, so I'm not going to go to the equity bars. I'll take volunteers. What do you think the distance from the distance DB is? We got Catalina, then we got Alyssa, then we got Michaela, then we got Brandon.
I got approximately 496,000.5.
Okay?
496,000.
Okay?
496,493.
Oh gosh. Approximately 496,000.
yeah.
Approximately 496,494. Anything close to that, I will accept. So, let's talk about approach. I've done the question myself quite a few times already. There's quite a few approaches. There's one approach. First of all, we are looking for dB. But the relationship that comes out of the geometry is this number squared equals this times the whole distance. So there's two approaches. We can either say BC is x, and then the whole distance becomes x plus 83,000. Or we could say that the whole distance is x. We could say that this whole distance here will be x. And that will actually simplify our lives a lot. But, one second, Michaela. But both approaches will get you the right answer. Here's the problem with the first approach. If we make this x, here's the equation we can set up. 203,000 squared equals 83,000 times x plus 83,000. If you're like me and you decided to distribute this, we get a gigantic number that the calculator can only handle in scientific notation for that. And then for this, you get a number that the calculator can handle without scientific notation, but the calculator can't store both numbers. and trying to write them down and then type it back in became really, really difficult. So if you take the other approach, oh, and I'm sorry, if you solve this and get x, at the end you have to add in this to get the answer, because the answer is looking for the distance from here to here, not just x. So you have to remember that step at the end. The other approach actually simplifies all of these issues. 203,000 squared equals 83,000x, but now x is the whole distance. If you're not aware of that, then you'll make a mistake. This simplifies things with the calculator because you can type this in, then divide both sides by 83,000 while the number's in the calculator, and the calculator will do everything for you. There's yet another approach stumbled upon by one of your classmates, and then several others caught on. Sebastian, what was your suggestion?
Oh, take out both zeros.
So, Alicia, you were able to articulate this properly. Not just take out all the zeros, but what are you actually doing? And then what do you have to do at the end? Multiply by 1,000. Since both numbers are divisible very easily by 1,000, divide them both by 1,000, but then at the end you have to multiply by 1,000. So here's what you would end up if you follow Sebastian and Alicia's approach. 203 squared equals 83 times x plus 83. Now all of a sudden, doesn't seem so difficult. And at the end, you have to add on the 83,000 or the 83 and then multiply by 1,000. No matter what, any of these approaches will get you the right answer. And of course, we get an approximate answer. So Michaela, you've been waiting patiently. Go ahead.
I don't know, maybe it was luck, but when you came around and I asked you the first time, you said that I forgot the x plus the 83.
Well, first I asked you what was x.
Yeah.
And you said x was BC.
Yeah, by accident. But if I did 83x equals this, what 203 squared is, and I got the right answer.
That's right.
Without knowing.
That's right. It's all about what x is representing. If you're representing x as just BC, at the end you have to add in 83 or 83,000. If you're having x represent this whole distance, then you don't have to do that step at the end, but you have to be aware of that. That's a critical choice in your path of logic and your approach to the question. Okay? So yes, this would have worked as well. 203 squared equals 83x. That's by far the simplest approach. But you have to be aware of what's happening. This, based on our experience, was the most logical. This works by far the easiest. Okay? Any questions about that? Any concerns? Comments? Anything? Go ahead.
Does that only work when they have the same number of zeros?
No, I'm sure you could take that approach anytime you'd like. Yeah. All right. Checkpoint number 3. And this is not a team challenge, it is independent challenge. So we're going to finish out, and I want to clarify what is happening here, but let me set the clock first. We'll have, we'll say 6 minutes. This x is representing the distance from A to B. This y is representing the distance from B to C. And you were also told a bunch of distances in the text of the question. You do not have to copy any diagrams or any text, but you need to find me the values of x and y. Any questions or concerns about that? Good luck and go. Yes, I'm sorry. DC is a tangent. I should have had that in the text of the question. I apologize. DC is tangent to the circle. A is right here. B is there. X is the distance from A to B. B is this intersection right there.
Or Spanish. That's why we're English. We leave each other straight. We're not. Okay, B is 14, EB. How can you be 3 What? No, it doesn't say it. I don't think so. Yeah, it's a little off. Yeah, but why are we assuming something? EB is saying but why would he assume that? You know what's we can't just assume that because why because he's assuming that it's perpendicular. No. You can't just assume all that. Okay. Wait, run about Wait, what? You're just saying that. How is that even a 3 4 5 yeah. You making sense?
No, I mean, I understand. I'm telling you Yes.
So then CD still plays on like CH where you okay, B O is 14 equals Isn't this what we're doing? Because I'm doing that.
There's no.
Because it's a small tangent.
All right. Normally I would give you extra time, but we have run out of time, so I will put you on the spot this time. Let's see how we did. I've got student number 3, 20, 8, 1, and 5. Student number 3, give me both values.
For X, I got 4. I didn't get 1 yet.
Student number 20. Student number 8. Student number 1. Student number 5.
X equals 4, Y equals
That's not correct. Hold on, that's not correct, and I don't know why.
Same thing.
X is
You
4 and
counted-
Y
Mr.
is
Gallant,
8.
Mr. Gallant,
So-
you added A to D when you did it.
No, hold on. Yeah, I don't know what I did.
Yeah.
So I apologize. X is 4. X is 4. And Y is 8. So I apologize, that's my mistake. I believe I changed the problem at some point and I neglected to update the answer. So to be quite honest, if you found X, you should have found Y very quickly. If you couldn't find X, I understand, but it wasn't, the question we did a few minutes ago was even harder. Unfortunately, I'm out of time, so we'll have to explore this at a different date. Your homework is on page 684. You're doing numbers 13 through 19, 20, 24, and 27, A and B. 19, 20, 24, and 27, A and B are all in bold. That is because they are the questions where you should be spending your time. 13 through 18 should be much quicker. Take some time to do the at-home tutor or read the next section. And a reminder that your EOC is on May 4th and